Alright, up to this point we've talked mostly about the drawing object. Let's do a little bit of image processing. Let's do a Gaussian blur. Every once in a while you need to do a Gaussian blur or a edge detect or a sharpen or something like that. And the typical way to do this is with a convolution kernel. Or maybe you're Googling something and you see this crazy looking thing like the Laplacian filter. Well, you can do all that in Howler using the VB kernel class. So let's start there. We got our classic bicycle looking thing here, and let's try to do something to it. We've created a new VB kernel object, and we call it k.Gaussian. This sets up a Gaussian kernel for us, and later we'll take a look at what that looks like. But now let's just go ahead and apply this to the image. And really all we have to do at that point is, let's see, refresh the screen. So let's see if that works. Run it for a few moments there. And Viola, we have our slightly blurrier image. Let's run it again. It should get even a little bit more blurry. Viola. It's a large violin. I don't know why people say that. Anyways, so there you see that it's working. That is applying a Gaussian or Gaussian filter to the image in Howler. And I'll put the original back in there just to show that yes, it did indeed get much blurrier. I can switch back and forth between them. All right, so what is happening here? And by the way, that was just like a couple of lines of code. That's working really well for us. All right, what is happening here is we set up this kernel, this Gaussian kernel, and we apply it. But what is it? Well, it's this, like we saw over here, it's this little grid of numbers basically, and you enter these numbers, and that makes up your kernel. What this represents is the neighboring pixel values of a given block around a single pixel, and it applies this mathematical looking thing to every pixel. The center value represents the current pixel, and these ones next to it represent the ones in front and behind and above and below it, and etc. So this is basically saying we'll take 4 parts of this and -1 parts of that and -1 parts of that, and then sum them all together, and what you get is the final pixel value. And the final result is basically depending on what kernel you use. Had I used a tent filter or a box filter or some other type of filter, I would have gotten a different look. Let's try a box filter. Let's see what that does. Go back to our original and apply that. And oops, that could possibly be a bug. Not going to worry about it for now. I will check that out. I'll make a note of it. Let's see. Let's do get kernel. All right, let's go ahead and do the Gaussian. And let's get a copy of that. Let's see what this does. Let's see. There we go. All right. And this should be a copy of our kernel. Let's see. For some reason we're getting an extra row and an extra column, or vice versa. Let's see. Put a, what is it, a comma or a, forget how you do this exactly. See if we can format this a little bit better. All right, let's try this again. If I remember. A comma actually. All right. Debug actually. All right, there we go. Now we have a good representation of what our kernel looks like. It took a little getting there, but you can see there's a small value on the outside. That's the middle value there. The largest value is right in the middle, and then there's a very small value on the outside. And then it grows slightly towards the center row. What did I call it? Yeah, row, the center row, and then it goes back down. And as it goes from this side to this side, it starts out small and it gets bigger, and then it goes back down. So this is basically like a smooth shaded sphere shape, and it is just basically the kernel that we're using to blur this. Now, what I would recommend is going on to Google and just googling convolution kernels, and that'll explain it way better than I can. I'm just showing that indeed Howler does have support for convolution kernels, and it is easy to set up and easy to get going with. And that's about it for now. I'll just show a few other things that it can do. There's in an eval. It wouldn't be particularly high performance running through the COM interface, but there is an eval that will evaluate a single pixel. If you need that capability, there is normalize. Say you put all these values in, but they had a little bit of a floating point error or something, and it didn't average out exactly to 1. Well, you could normalize that, and then that would make them all average out to 1. And then there's let's see, there's also set row. Say you want to create your own convolution instead of using one of the built-in ones. Well, you just let's see, let's do 1, 2, 3, 2, 1, and also give the row. That'd be, I think, forget if it starts at row 0 or row 1, but let's find out. Let's see. Should be 1, 2, 3, 4, 5 of these, right? All right, then we'll just duplicate that. All right, and then we also need to put the row on there. Then once we've done that, we will definitely want to normalize those. And then we do k.dot apply kernel, and then we'll refresh the screen so we can see it. Oops. Let's see what happens anyway. Let's see, argument not optional. That should actually be apply apply to image, and